Okay, so let's look at 2.1, which is simplifying expressions. So some of this you might have already learned, and some of it's going to be new. So we're going to build upon what you learned in 6th grade with expressions and equations and inequalities this unit, but then add some new stuff to it. So let's just go over some basic vocabulary to kind of refresh ourselves. The first word is variable, and a variable is a symbol for an unknown number. So it's a symbol used to represent. So it's a symbol used to represent an unknown number. So an unknown number or value. So, and that looks like X, Y, or Z, okay? Not even or, but any letter. So commonly you'll see X, Y, or Z, but it could be C or A or whatever letter of the alphabet that you want to use to represent an unknown number. Okay, so then let's talk about what a coefficient is. So it's a number that is used to multiply a variable. Multiply with a variable to make that more grammatically correct. Okay, so an example of that would be 4x or negative 7y. The coefficient in 4x is 4, and the coefficient in negative 7y is negative 7. Okay, so it's really the number that comes before the variable. Okay, a term is a lot of things, so this definition is going to be a little long. Okay, a term is a number. It's a number, a variable, or the product of numbers and variables. So it's can be a number, a variable, or the product of numbers and variables. Okay, remember product means to multiply. Okay. What's important is that terms are separated They're separated by the addition or subtraction sign. So terms are separated by the addition or subtraction symbols. Okay, and that's how you know that they are separate terms. Okay, so now that we know what terms are, let's look at like terms. So like terms are terms that are exactly alike. So terms that are exactly alike. So they're terms that are exactly alike. And what that means is that it's the same variable to the same power. Same variable raised to the same power. So their variables need to be exactly identical. Raised to the same power. Okay. Now, there's some things about like terms. So remember we talked about coefficients. Coefficients can be different. So coefficients, they can be different numbers as long as the variables are the same. So coefficients can be different as long as the variables are the same. So let's put that there. Variables must be same. Okay, so the variables must be the same. And constants. Constants, they are just numbers alone. So they are like terms. So constants, they are like terms. Okay, even though they could be all different numbers, because they all don't have variables, that's why they're alike. Okay, let's talk about what is an algebraic expression. It's an expression with integer constants, variables, and algebraic operations. So it's an expression which is essentially just a bunch of numbers, an expression with integer constants, so it's pretty much a line of numbers that can also include variables and can also include addition, subtraction, multiplication, and division. So those are your algebraic operations. Okay, so now that we have some definitions down, let's get to some math, okay? So now that we have these couple of definitions down, let's keep on going. So let's look at example 1. So it says evaluate the following: 3x plus 4 when x is equal to 2. So we have 3x plus 4 when x is equal to -2. So what that tells us to do is anywhere we see an x, we're going to plug in -2. So anywhere I see x in my problem, it's going to be right here, I'm going to substitute this -2 in. So I would write 3 times my -2, and then now I just have plus 4. Okay, so now I want to simplify that. What is 3 times -2? Well, it's -6 plus 4, and then -6 plus 4 is going to be a -2. Okay, so what we just did is wherever it told us what x was, we plugged that in anywhere we saw x, which is what happened down here, and then we evaluated it. So we simplified that problem. Okay, so let's give you a shot at trying number 2. The first thing I want you to do is just plug in where this y equals 3 goes. So I want you to pause and plug in, and if you're feeling confident, simplify or evaluate all the way. Okay, so first step, plug in 3, and then keep on going. Okay, so the first thing I did was plug in 3 anywhere I saw y, and then I'm just going to simplify what this says. Okay, so now I have -15 minus 7 plus 12. And I know that this is a -22 plus 12, which is a -10. So you have to really be careful with your addition and subtraction rules. So you have to have those down pat. Okay, so you really have to understand those rules in order to be successful in this unit. Okay, so make sure you know all of those rules. Okay, so now we're going to talk about combining like terms. So we talked about what like terms are, but there's some steps in order to do this. So we're going to use shapes or colors, whatever you want, to identify our like terms before we do anything. So the first thing we're going to do is use shapes. Use shapes/colors to identify our like terms. Okay. So I'm going to do that on this bottom one here. So here, this problem is down here, and I'm going to show you what each step looks like as we write it down. So the first step is to use colors or shapes to identify like terms. I'm going to use colors. okay, because it's easier for me. So like terms, remember they have to have the same variable. So I have a 4x here. So I'm looking for something else with an x in it. Something else with just an x. And that's going to be plus 8x. So these are like terms. Okay. And then I have this plus 3. And I want to figure out what the like term is with that. But I know 3 is a constant. It's just a number. Remember we said constants are just numbers. And constants are like terms. So something else that's just a number is plus 7. So then those are like terms. So my next step after I identify what these like terms are is I'm going to rewrite this expression with them together. So I'm going to rewrite the expression and to put them together. Okay, so I'm going to rewrite this. I didn't really leave myself a lot of room, but I think I left you more room. So just be wary here. So I'm going to put everything in red together. And I'm just going to keep the signs. So that's what else we could put here. Keep signs. Okay, so we're not going to change any signs. We're just going to leave whatever signs they are. So since these are both plus, they stay plus. And now I have plus 3, plus 7. So now I'm going to combine them. So I'm looking at 4x plus 8x. When I combine my like terms, all I really do is just add up my coefficients. So what's 8 plus 4? That gives me 12x. And I just bring the x along. If it has a variable, just bring that variable along for the ride. And then I have plus 3 plus 7, which a positive 3 plus a positive 7 is a positive 10. So this simplifies to 12x plus 10. Okay, so let's look at one more example together. Oh, sorry, I missed some steps here. So step 3 is what I did here. We just simplify. So this is really when we combine our like terms. This is really when we combine them. Okay, so this is really our combine like term step. And as I said, for variables, all you do is add their coefficients together. Okay, and I said all of that, but just in case you missed it, there it is. Okay, so I'm just going to move this up a little bit so I give myself some more room. So step number 1 is to use colors or shapes to identify their terms. So I'm going to identify some like terms. So I want to find everything with an x in it. So I have 3x, and then I have minus 5x. I always highlight what sign or what operation it has, that term has with it. So that way I know whether it's positive or negative when I go to rewrite it later. Okay, and I know 4 is a constant because it's just a number. So then also with it is just 10. Okay, so we're going to rewrite our like terms together. That's step number 2. Rewrite the expression to put our like terms together. So I'm just rewriting them as they are. So I have 3x minus 5x. And I have plus 4 plus 10. And then the next step is to simplify. But for variables, we just add our coefficients. So what's 3 minus 5? 3 minus 5 is negative 2. And then the x just comes along for the ride. And then we have 4 plus 10, which I know is 14. So then example 3 simplifies to that. Okay, so I want you to try example number 4 for me. I want you to take a moment and try example number 4. So pause and try that, okay? So hopefully when you did that, you get 11w minus 3. Okay. So now let's look at the next page. So I want you to try example number 5 for me. So I hope you're feeling a little confident. Now I want you to try example number 5. So let's dive in deep. Now for example number 5, you should get negative 3x, and that's it, negative 3x. So you may be thinking, well, how do we get that, right? So our like terms are 3x, negative 2, and negative 4. So let's write those out. Okay, I know 3 minus 2 is 1, minus 4 gives me negative 3x. And then I have plus 4 minus 7 plus 3. Okay, and I know 4 minus 7 is negative 3, plus 3 is 0, and I wouldn't write plus 0. Okay, so hopefully you just got the answer of negative 3x for example 5. So example 6. I hope you're looking at this and you're noticing something. There's x, and then there's y's back here. So they are not the same variable, so those are not like terms. So our x's are like terms, and our y's are like terms with each other respectively. So our y's are together, and our x's together, and then our constants together. So I want you to finish the rest of this problem out, and I'm just going to put the answer out here. So now that I've helped you identify the like terms, I want you to write out what you get after. Okay, so hopefully you got 5x minus y minus 4. So make sure you have work here, because I'm not going to stamp you off if you don't have work. So unit 1, maybe you could have gotten away with not showing work, but in unit 2, if you don't have work down, it's going to be impossible for me to figure out where you went wrong. Okay, so you really, really need to show some work. It's pretty much not an option anymore. Okay, let's keep on going. So we're going to be using the distributive property. So we've talked about the distributive property in 1.11. So we vaguely talked about that. And all this property tells us is that we distribute this number out front to both of these numbers in the parentheses. So what this is saying is we distribute this 2 to the p and that 2 to the plus 1. And by distribute, we just mean to multiply. So distribute, we really multiply this value in. So multiply in is what I would say. So 2 times p is 2p, and then 2 times 1 is going to be 2. So we distribute that 2 to both of those values, and that's how we get 2p plus 2. Okay, so now we're just going to dive right in. Example 7. So the first thing I'm always going to do is to distribute the value in. Okay, so 2 times 5x, or really 2 times 5 is 10, and x comes along, and then 2 times a minus 3. You can't ignore that minus 3. So this becomes minus 6. And I'm just going to rewrite the rest of the problem. So we distributed in, and we got these numbers. And then I just rewrote the rest of the problem and brought it down. Okay. So now I'm going to combine my like terms, which I have 10x minus 2x. And I'm going to rewrite them together. Then I have minus 6 plus 14. And this gives me 8x. And this gives me 8. So then our answer is 8x plus 8. Okay, so I want you to try example number 8. So I want you to pause and try example number 8. Okay, so before you get too far, this is a -5. So we should be distributing a -5 into both of those. Okay, so that's really, really important that you distribute a -5, not just a 5, because that's going to change some of our signs. So hopefully now you'll be able to go back and fix some mistakes if you made any. So I have 2y, 5y, 4y. So 2y, 5y, 4y. Okay, so I'm just going to keep on going. And that gives me 1y. Okay, and then I have 3 and 10, so plus 3 plus 10, which gives me 13. So my answer is y plus 13.